In this module, I shall discuss how to access the address of a value, store it, and use it in different operations. You will learn how to declare and initialize pointer variables, how to reference and dereference a value, how close array names and pointer variables are, and finally, how to return a pointer from a function. A pointer variable, commonly known as a pointer, holds the memory address of another variable, allowing you to indirectly manipulate it. An integer pointer holds an integer address, and a char pointer holds a char address. When declaring a pointer variable, an asterisk is placed before the variable to indicate that it will hold an address. If you try to assign a variable to a variable pointer, it will result in error because pointers only hold memory addresses. Below, you can see how a pointer is declared. The address operator ampersand returns the address of a variable and should not be confused with the reference ampersand. Here is an example. We declare the variable number with the value of 5. We then try to assign the address of the variable without using the address operator, which gives us an error because it tries to initialize pointer ptr with a value. Trying that again using the address operator, we get the correct result since it is initialized ptr with the memory address of number. The memory address of a variable is the address of the first block of memory. Here we have an example with a char, short, and integer variable. Different variables take up different amounts of blocks of memory. To a pointer, the amount of space that a variable takes up is irrelevant, since it only points to the first one. This is also why pointers need to be declared with types. The program needs to know how to interpret the blocks of memory that follow the address that the pointer holds. The indirection operator before a pointer makes it point at the value instead of the memory address. This is also known as dereferencing a pointer. So printing a pointer with the indirection operator would result in printing the value that the pointer points to. If we try to print to add the indirection operator to a variable, it would result in an error because number is not a pointer. Here we have a program that illustrates the operators we have mentioned so far. First, we declare a variable called number and initialize its value to 10. We then create a pointer called ptr and assign it the address of number. After that, we print the variable, showing its value, and then use the address operator to print its address. The memory addresses are in hexadecimal. Later, we use the indirection operator on the pointer to print the value of the variable that ptr is pointing to, which in this case is number. We print the pointer to see the address of number since it is the variable it's pointing to. Finally, we use the indirection operator again to change the value indirectly through the pointer. After assigning number the value of 20, we print it on the console to see the result. Previously, we've seen that the name of an array holds an address, and that the subscript is used to select the element of that array. In the following statement, array name value is holding the address of the first element in the address. The array name value is a constant pointer variable, so they hold the address of the first element of the array. Array names are also constants. You cannot assign another memory address to the array value, or it will result in a compiling error. We've also seen pointers when passing reference variables as arguments. In the following diagram, the variable age contains the address operator ampersand before it. So instead of making a copy of the original value, it gives it the variable address, allowing any changes to be reflected directly onto the original value. Take note that age is not a pointer variable, but it is being initialized with the same address as your age, so it is pointing at the same memory address. When using arrays, if we want to have access to the elements using the array name and pointers, we have to dereference the array name as following. By dereferencing the array name values, you get the value in the first element, that is 1. Since in arrays the values are stored in order, to retrieve the values inside the other elements, you simply move to the next space in memory by using parenthesis and adding the number of the element desired to access. For example, printing values plus 1 would result in printing 2. Printing values plus 2 would result in printing 3, and so on. To demonstrate the relationship between pointer variables and array names, we're going to print the values from 1 to 5 using subscripts on the pointer to select the element and using the dereference asterisk on the array name. As can be seen from the program output, both methods give identical results. As a final example, we create a program that takes the contents of an array of 5 numbers and then multiplies it by a number entered by the user, sums them all up, and prints it on the console. For this, we shall create 3 functions, one to get the number by which the arrays will be multiplied, called getNumber, and another to get the numbers of the array from the user, called getValues, and a final function that will multiply the elements of the array, sum them up, and return the address of the variable that holds the value. These 3 functions will use pointers as their parameters. Keep the following things in mind when using pointers in functions. To return an address, the data return type in the header must indicate that it returns a pointer. To send an address in a function call, use the address operator, unless it's an array name. When a function receives an address, you must declare the variable a pointer in the parameter. Back in the program, the function getNum receives an int type pointer. It then dereferences it when it receives input from the user. It does not need to return a value since it operated on the variable that the pointer was pointing to and not a copy of it. The function getValues uses a for loop to receive the values of the array, but instead of using the array's index, it dereferences the name of the array, since it is a pointer, with an offset to the respective element which is to be added. The function multiply receives a pointer to the value that will be used to multiply and the array name. The function then uses a for loop similar to the one used in getValues to multiply the numbers. As they are multiplied, the sum of their values are stored in the first element of the array and then assigned to the variable sum, which was declared inside the function. After all the values have been added up, the function returns the address of the variable sum. In our program, this returned address is assigned to a pointer of the same name. That pointer is then dereferenced to print the final result. From the program output, you can see the results of this program. The user enters 2 as the number used to multiply, then enters 1, 2, 3, 4, and 5 as the values of the array. The program then does the calculations and prints 30 as the result of the program.